All right, I wanted to show you a couple of the new labs that are available in CyberDefense. This one is Exploring a SQL Injection Flaw, and this lab is, if you remember this lab from Ethical Hacker, it's significantly enhanced. In this case, the student gets a chance to kind of explore what a SQL injection flaw is, so we'll go ahead and get that started. They're going to be testing their online secure bank and making sure that things are safe there. In case, as we've set up the scenario, obviously it's not. One of the things you can do in our scenarios, which is kind of cool, is you can highlight something that's kind of long that you don't want to type in. You can let it copy to the clipboard and then you can just paste it in. So if you don't want to type mysecureonlinebank.com, you can just do that. So the first thing we want to do in this lab is type in the actual account number and see what happens. So 90369 is the account number for this user. So you click on lookup and it says, hey, good day, Olivia Martinez. Your balance is $10,625, which is pretty cool. And it reminds us to answer question 1. We use the questions in the lab to kind of guide the student through some of these labs that are a little more exploratory. And so those questions help them know where to go. And so in this case, we're checking that they've done this by having them enter the balance. So 625.79 is the balance for this account. So the next thing we want to do in this lab is to begin to investigate how much validation on the input this website is doing. And so we'll type in the number 1 just so we know where we're at. And if we click on lookup, you'll see that it says, oh, you haven't entered a valid account number. So it knows that a one-digit number is not going to be a valid account number. If we put in 2, it knows that 2 digits is not a valid account number. 3, 4, and then once we put in 5, you'll see that things change a little bit. Oh, now that we've put in 5 digits, it says, okay, well, it's not telling us it's not a valid account number, but it's not telling us that it found an account number. So at least it's checking to see that you're entering in a 5-digit number. If you keep going, let's do 6 and 7. Interestingly enough, it's not telling us that it's a bad account number. It's just telling us that it didn't find that account number. So if you look at the question over here, one of the questions says, how many digits are required to be considered a valid account number? Well, as long as it's got 5 digits in it, it's going to say, okay, this must be some sort of a valid account number. So in the world of SQL injection, that leads us to believe, well, gee, can we enter in additional information? So I'm going to type in my account number, again, 639, and I'm going to add some additional information to it. In the scenario, it suggests typing Bob or cat or dog. And if we type in Bob, you'll see that, oh, it took my account number and it gave me the information, but it didn't care that I had put additional information after the account number, which kind of gives us an indication that this is going to be vulnerable to a SQL injection attack, because it's going to let us put other things in there. So you can see, oh, we forgot to answer the question over here. What can you determine from these inputs? Well, the input is not restricted beyond the first 5 digits. So we found that, hey, we can put extra stuff in there and it's still going to give us our account number. So with that information, knowing that we can put extra stuff in there, let's try a couple of simple injection attacks. So we're going to put in our account number, and then we'll just add or 1 equals 1. And basically, whoops, that's not equals, 1 equals 1. And what this is basically saying is I want my account number or true. So I want, basically it's saying I want any account number. And so if we click on lookup here, well, gee whiz, we got everybody's account number because we told it to give us everybody's account number where account equals where it's true. And so we got the whole list of things here. So just to verify that the student's kind of following along with us, we ask him for the account number of Ocean Padilla here. And so his account number is 90006. And we put that in. So we're going to try another simple SQL injection attack where we're going to try and we're going to try and add some information. So we'll say, tell us our account number and who am I? And so if you do account number and who am I and click on lookup, you get your account balance, but you also get return the user that the web server is using. So that web server is using www.user or -user. So once we've got that information in there, we can click on Score Lab and it tells us we've answered the questions correctly, but we've guided the students through kind of evaluating whether or not this is this website is vulnerable to attack. So I'm going to go ahead and close that, and we'll go ahead and jump ahead to the next lab, which is the SQL Injection Lab with using Burp Suite. We're going to do a fuzzer test, and what that means is we're going to use Burp Suite to try, instead of us trying to do this manually, we'll use Burp Suite to, I'm going to go ahead and start the lab. We're going to use Burp Suite to try lots and lots of potential SQL attacks to see if any of them are successful. So, why do it manually if you can have a computer try hundreds and thousands of different possible attacks for you? So we'll go ahead and start Burp Suite here. Burp Suite is a tool that kind of acts as a proxy between your web page and the web server, and it gathers the information, and you can do all sorts of fun things as that web information passes through Burp Suite. Now, we've already gone ahead and set up the browser so that Burp Suite is the proxy. And we'll go ahead and start Burp Suite in the Community Edition. The very first thing we want to do, since we've got the proxy set already, is we want to come into the proxy and tell it to turn intercept off. And what this is doing is it's telling it not to intercept the traffic, but just to let the traffic pass through Burp Suite and watch it. And then we're going to click on HTTP history so that we can see what's going on. And we'll just kind of hold off here. We're going to go ahead and bring up our browser now. And once again, we'll just copy the information so we don't have to type the big long bank name there, My Secure Online Bank. And we'll go ahead and hit enter. So here's My Secure Online Bank popping up here. You can see that the first couple of web requests show up down there. And now let's go ahead and put in our account number, 90342, and hit lookup. We get our account balance back. We're like, hey, that's so cool. Okay, so now down here in Burp Suite, you see this request for the 90342. What we want to do is tell Burp Suite to try lots of different things instead of 90342. So the way we can do that is we right-click here and we select Send to Intruder, and that sends everything about this, the host, the method, and all these things. It's going to send over to the Intruder tab, which is where we're going to do our fuzzer attack. So you can see that already here it's got a target for My Secure Online Bank. And if we click on positions, it shows us this is the web request that was being made. And so what we're going to do in a more complex system, you may have several kinds of requests being made. In ours, we just have the one. And so you would want to clear them. But in this case, we'll just go ahead and say, okay, this is where the request information goes. And we're going to click on add to add some little delimiters there, so that we know this is where the fuzzer attack is going to take place. It's going to insert lots of different things in here and try lots of different possible SQL attacks automatically. So next we'll click on the Payload tab, and the Payload tab is going to give you a chance to see what they're going to be using. So in this case, we've chosen a simple list, and the simple list down here has several different common kinds of things that you would use in a SQL injection attack. We've trimmed it down to 50 for purposes of the simulation, so the student's not sitting here all day. But with Burp Suite, you can actually use hundreds or thousands of these and try all sorts of different common attacks to see if your website's vulnerable. And there's even more, this is a simple list attack. There's even other more complex attacks that you can choose. So knowing what we're doing here, we're going to go ahead and click Start Attack, and it's going to go ahead and continue. Burp Suite will take each one of these possible SQL attacks, and it's going to insert that in place of our account number. So here we go. We'll click Start. And you'll see the very first one is actually our account number. And so if we click on that, you'll see down in the bottom here that we got the Good Day Blake Jackson. You got your account balance. But then it tried the little, just a quote mark. And if you scroll down and look at what that happened, it says, oh, hey, you got a SQL syntax error. So it didn't like that one very much. And if we click on the next one, which is just a double quote, it comes up, and basically we got nothing back on that one, just a blank response. And if you click on the pound sign, it comes back and says, oh, that's a bad request. The web server didn't like that at all. And then if you look on the next one, another blank one, and so we'll see some of these. So to kind of guide the student through evaluating this, we use the questions again. And so if we click on answer the questions, it says, okay, which kind of response did the equals %20 quote mark give us? And if you look at that, that's this one right here, number 9. And it says you have an error in your SQL syntax. So that one wasn't a successful attack because it just was a SQL error. And then it says which response was received from the or equals 0 pound sign attack. So let's go scroll down and find that. Let's see, it was quote or equals 0 pound sign. So I believe that's this one. And that one says bad request. And so that one was a bad request. And then as you scroll down through these, you'll notice that the sizes of these are different. You can kind of determine which ones are which. You know, the ones that are in the 850 range, they're the SQL syntax ones. The ones that are in the 700 range, they're the blank ones. The ones that are, 728 or so, well, that's a blank one too. But you can see just by the different sizes, you can kind of tell which ones are which. And there's a couple of them that stand out here, specifically the ones that are in the 6,000 range. And if you notice, those gave us the whole database dump, just like we got when we had a successful attack in the previous lab. So these particular ones are the ones that are successful attacks, indicating that your web server is vulnerable to SQL attack. And it lets you know that there's some issues that need to be corrected with that website. So as you scroll down through here, these 50 attacks, there's a half a dozen of them that give you the large, attack successful. And then as you look at the rest, you'll see that there's the various different SQL syntax errors and the different pieces as you go through those. The last question guiding the student says, okay, well, tell us one of the request numbers for one of the successful attacks to let us know that they identified some of the successful attacks. And so here's one here, number 39. So we'll go ahead and type in 39 here, and we'll go ahead and hit score this lab, and it'll come up and tell us that, hey, we got those answers correctly. But the student learns as they go through this that, hey, this is how you are able to automate the checking of a SQL injection flaw, and they're able to see how some of these tools work that allow you to check that in a much more efficient manner than just trying to do it manually. And so I hope that gives you a little bit of a flavor for some of our labs. We try and guide the student through learning the pieces that are important for them to see.